Alright everyone, we're continuing into lesson 4, and we're going to continue working on a few more mental math evaluating problems. The reason we're doing a few more is because these are a group of kind of special cases that I wanted you guys to be aware of. So remember, with mental math, convert to exponent form, and then ask yourself, what power of the base will give us our result? So here we have log base 3 of 0 is equal to question mark. So we have base 3 to question mark is equal to 0. Now this is a special case because there is no exponent that will give us a result of 0. No exponent can do this. So, no exponent works for this case. So this is a case of the question mark is undefined. So this is the only case where we have undefined. All right, the next one, log base 1/4 of 16 is equal to question mark. So our base, as you can see, is a fraction. 1/4 to the power of question mark is equal to 16. Now, one thing you guys need to be aware of. Anytime your base is a fraction, your question mark is going to be negative. All right? Heck, anytime you have a fraction somewhere in your exponent, whether it be the base or what it's equal to, the exponent is negative. So that's what we're going to start with. Then, just ignore the 1 and ask yourself, what power of 4 will give us 16? Well, that's going to be 4 times 4. So it's going to be -2. Again, it's a negative because we have a fraction. And then finally, our last one, log base 2 of 2. And this 2 is also raised to a power 8 is equal to question mark. So our base is 2 to the question mark, and it's equal to the whole thing, 2 to the 8th. Now, if you notice, both our bases are 2. They're the same. And since the equal sign is between them, that means the exponents also have to be the same. So our question mark is equal to 8. And there you go. As you can see, we did not use any calculators. So when you guys do these problems, you should not need the assistance of a calculator. All right. Now we need to talk about 2 different types of logarithms that you're going to encounter. The first is called a common logarithm. So the base 10 logarithm is called the common log. With this, you don't write a base with the log. What this means is log base 10 of x, we would actually write this as just log x. So as you can see, there is no base, but think of it as like an invisible 10 is here, okay? We just don't have to write it. The next type of logarithm is called the natural logarithm. This one has a base of e. So the base e logarithm is called the natural log and is written with an ln. So what this means is, if we had log base e of x, we're actually going to replace log base e and write it as natural log of x, ln of x. So, you guys will have to rewrite exponents and logs in this new format. So here, what is the logarithmic form of 10 squared is equal to 10? So, log base, oh, it's a base 10, so I do not have to write 10 of 100 is equal to 2. So anytime your exponent base is 10 and you're writing it as a log, you just write log with no base and everything else. Here, what is the logarithmic form of e to the x is equal to 8? Anytime your base of your exponent is e, automatically write ln for natural log. Then we don't have a base because it's built into the natural log. So natural log of 8 is equal to our exponent, which is x. All right, now we're going to go to exponential form. Here we have log y is equal to 5. So there is no base, but remember, to go to exponential form, when there's no base in the log, our base of our exponent is 10. And then our exponent is 5 is equal to y. Same thing here, exponential form of natural log. We see natural log, the base of our exponent is e. And then the exponent part is 6 is equal to x. So those are the special cases you have to be aware of when converting. Now, with these guys, these ones you will be evaluating with your calculator. So evaluating common and natural logs, these you do have the ability to plug into your calculator. We cannot plug the logs into our calculator that have a base of a different number. But here, since the base is 10, calculators are programmed to do this. So what is the value of each logarithmic expression to the nearest tenth? So let me grab my calculator. So you'll just have to look for the ln or the log button. So our first one is log of 900. So 2.95, so this is going to be 3.0. All right, natural log of 15. 2.7. And so on. This next one, natural log of e. Oh, just 1. And then we have log of 2.34, 0.4. So, nice, quick, easy calculator ones. And there we go. Our intro to logarithms is now done.